All right, guys. So we're going to area as a product and the sum, the notes. So the first thing is we're gonna deal a little bit with algebra tiles. That's from last year. So just a reminder. Let me see if I can get it closer. There we go. Just a reminder, algebra tiles. There's a tile 1 by 1, and the area is 1 times 1, which is 1. Algebra tile x time x. The length is x, the width is 1, so area is x because 1 times x. Y for length, 1 for the width. The area is y. You have a tile that is x by x, so the area is x squared. Tile y by y, so the area is y squared. And there's one also x by y, so the area will be xy. So now we're going to talk about area. Sorry. We're going to talk about area and perimeter of polygons created by algebra tiles. Okay, so if we're talking about perimeter, we're going around. So I marked everything that I know. If this is the little square tile, that's 1, 1. This length is 1. This one, it tells me it's x. So from this, I know this is a square. So I know this length is x. So those lengths also have to be x. So I got x, then 1, 1, 1 again. This length is also x, since they're all x here. And then I have 1, 1, 1, x, 1 over here, 1 over here, 1 over here, 1 over here. Okay? So if I do perimeter, I'm just adding. I'm adding all the x's. X, x, x. I got 3 x's. And then I'm counting the side of the square. I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. That's my perimeter. Now, area, guys, is you can either go over there and look at the areas, what's each area. But I have an area of square 1 by 1. So area is 1, so I have 3 of those. So 3 times 1. I have one big square x by x, so the area is x squared. And I got 3 rectangles x by 1, so the area is x. So my final answer will be x squared, 3x, and 3. Now we usually want to write it in order of highest power to no power, meaning no variable. So x squared first, then x, and then no x's. Okay, if you leave it like that, that's okay, but that's not the proper way in math. It's kind of like in English writing with capital letter. The highest power is your capital letter. Okay, that makes sense, maybe. Okay, so we have another example of area and perimeter. So let's start. Oh, I forgot the area. Look at this. Let's stay. Let's start with perimeter. So I went around and marked everything. So if this area is x squared, that means the sides are x's. So that will be also x. If this is y, that means those are y's. Those are all ones. The problem was with those little pieces here. Okay, it's not y and it's not 1. So what is it? Well, the whole thing is y, but I have to take away the 2 ones. So this little piece is only y minus 2. And this little piece is even worse because the whole thing is y, and what we have to take away is x. So this length is y minus x. Now think about it as a variable. If this is 6 and this is 5, that will be 6 minus 5, which is 1. It will be a lot easier to look at it when we have numbers, but we don't. It's any number I can pick for this. So perimeter, I'm going around. Let's start with x's. I got 1, 2, 3, 4, 5. 5 x's around. That's where I got this from. Then I'm going to look at y's. I got y over here and y over here. So that's 2y. I know those include y, but I'm not going to touch them yet. I'm going to count them as separate pieces. Then I got 6, just the side 1. So 1, 2, 3, 4, 5, 6. That's where I got 6 from. And then I added this side. And then I added this side. So I got all the x's, all the y's, all the single ones, and then I have the little weird pieces. Okay, what happened? I combined them. I have 5x and negative 1x, so that's why I got 4x. I had 2y, another y, and another y. That is 4y. And then I have 6 minus 2, that's 4. That's the perimeter. My area, I got two areas of x squared. I got one area of y squared, this one. I got one area of y, and I got two areas of just ones. I can't combine anything. They have different powers and different variables. That will be my area. Okay, this is forming a one big rectangle, and we're going into areas and written as a product and the sum. What does that mean? Product. Well, you guys know the area of rectangle is base times height. So in other words, your base times height is the product. And then also area as a sum means I'm just adding, just like I did here, all the little areas inside. So if I add them all together, that's going to give me the sum, area as a sum. Okay, what does it mean for us? Well, if I want to know the base, I need to know the length of this whole side. So just like we were looking at the perimeter, okay, I have the length of this is x plus x, so 2x and 3, and then the height of this will be 3x plus 2. So if I want to write this as a area as a product, that will be base. Actually, I put a base second, but that's okay. Base and then times height. Okay, they're not single numbers. That's totally fine. They're expressions. They're still representing the length and the length. Now, how do I do area as a sum? Well, I'm adding all the areas inside. So I had 6x squared. Where did I get it from? 1, 2, 3, 4, 5, 6, right? 13 x's. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And then 6. This 6 is coming from those single ones here. And that now writing this as a area of product equals to area of sum. Well, area of product is this, and it's got to equal the area of sum because that's still the same area. We're not going to do anything with this right now. We just want to rewrite it as a product and a sum. Okay, so the next part of this is we're going to simplify a little bit. We're not going to be dealing with tiles all the time, okay? We're going to be dealing a little bit simple form. So we have this, it looks like a square. It can be also a rectangle. It doesn't really matter. And they gave me the sides of the single pieces, and they gave me the insides of those. So now area as a product will be base times height. So I put base times height. By the way, guys, if you notice, this big rectangle is represented as a smaller one instead of putting two x's here. Like in this, there was 2x. Okay. Oh, 2x. They just put 2x. And then instead of putting 3 ones, they just put 3. So it's really the same thing. It's just writing simple so we don't take so much space of drawing it and trying to rewrite it. Base and height. Base times height. They gave me the areas. How do I find the area? Well, this is 2 times 2. That 2x, so that's 4x. This will be 2 times 3, that's 6. This will be 3x times 2x, so that's 6x squared. And this was 3x times 3 is 9x. Now, the plus here, guys, it doesn't mean we're adding. It just tells me it's a positive number, okay? So don't mix it with we have to add it. It wouldn't be 3x plus 3 as an area. It's just telling me I have to use positive number when I'm writing the length of the sites. Okay, so a little bit more. In this one, guys, they only give us the inside. Oops. The inside of the rectangles and some of the information outside. So our job is to figure out the rest. So if they said, why is this so blurry? Let's see. Okay, better. Okay. So they tell me that inside the area is 3x squared, and they said one of the side is x. Well, so basically to figure the other side, you can do two things. You can think about it. 3x squared divided by x will leave me with 3x. Or you can think about what number and variable or what variable multiplied by x will give me 3x squared. So 3x squared, guys, is really 3 times x, right? So I have 1x already. I'm missing another 3x. So they give me area inside as 2x. Once I found this is 3x, 3x times what is 6x? Well, 3 times 2 is 6, and x was already there, so that's it. Now, this represents area as a product. So base x plus 2 times height, which is only 3x. There's no other addition here. And that equals to area as a sum, and sum meaning sum of the areas. 3x plus 6x. Okay, second example. They gave me x squared, they give me x, and they give me x over here. So I had to figure out the sides of it. Oh, they give me 1, positive 1. So if my area is x squared and one of the side is x, that means the second one has to be also x, because x times x is x squared. So question is, x times what is just x? Well, x times 1 is x. So my side over here is 1. It doesn't mean, guys, that x equals 1 because they look like they're the same. It's just a representation of area. So you don't have to look at it as like it's drawn to scale. Don't worry about it. Now, I didn't know what was the area here, but since I found this side of my rectangle, x, and the other side is 1, 1 times x is x. And then the other area is 1 times 1, and that's the area over here. Okay, area as a product. Product means the length. X plus 1, and then x plus 1. When you guys are writing this, we do not write this. This is weird looking, just like the one I was telling you. Powers, higher powers first. So if you have variable, you put it first. So we don't want to write this. We write x plus 1. Okay, and the area as a sum is x squared plus, I already combined x and x here, so I wrote 2x and then 1. Now, if something repeats and you multiply it by itself, you can use powers to write less. So x plus 1 times x plus 1 can be written as x plus 1 squared. Okay, a little bit more difficult. Okay, guys, so look. We got, this was given to us, this, and this. I had to figure out how to do this. So I'm going to start with -4, and I had side of 2. So basically, 2 times what is -4? Well, 2 times -2 is -4, and I also need x, so that's why I put the x up here. Okay, moving on. I knew this was 2. I knew this was 3y. So this rectangle was 2 times 3y, which is 6y. And then they give me the area. That was -10. And since I know this is 2, I know this side is also 2. Because all of those are exactly the same. So negative 10 divided by 2 is negative 5. Okay, let's see what else I can do. Uh, how do I figure out this x? Well, I didn't have this, so I had to go to only thing that I have on the top of my rectangle, one of the areas. So what did I know about it? I knew that this side is 3y, okay? So I had 3xy. Well, we had 3 already, and we had y already. What we were missing for this is x. So that's why I put the side of this as x, and it also goes here. Knowing that opened a lot of things for me, because then I could do negative 5 times x is negative 5x. And also this time, x times negative 2 is negative 2x squared. So I have filled all my areas inside, and I know all my length. So area is a product. Base times height. I keep switching them. Base is negative 2x plus 3y minus 5 times height is x plus 2. Area as a sum, well, I just put all the insides. I add them all together. And then I started to combine them. The only thing I could combine is x's. So that turned into negative 9x. And everything else stayed the same. The last problem here was um, this was given, and those two pieces were given. Okay, so from this area and from the side, I figure out that my other side has to be 2x, because 4 divided by 2 is 2, and I have 2 x's here, x times x, but I only had 1, so I was missing 1 more. Okay, I didn't know this yet, so I'm going to try negative 9, to use negative 9. Oh, I can actually find this one, because I know this side is 2x, right? And I know this is 3, so 2 times 3 is 6, and x. Okay, let's move to 9. I know the area is negative 9. I know the side is 3. Negative 9 divided by 3 is negative 3. And that helped me to figure out the area here, because negative 3 times 2x is negative 6x. Area as a sum, well, I switched the order, that's okay. Area as a sum, well, I add everything together. The only thing is those two cancel each other, so I didn't even have to put them. And the area as a product is base 2x plus 3 times height 2x minus 3. Or something very interesting happened. The middle canceled, but if you look at those pieces, they're almost the same except the plus and the minus. So that guy is like a special one. We'll talk about those some other day. Okay, guys, have a good day. I'll see you next time.